In this video, we will be going over an example of the annihilator. If you want a formal definition and an intuitive video, there will be one soon, but for now we will just go over an example. So we are given the following problem. Let v be equal to r to the power of 3 and u is equal to the span of 1 minus 1, 1, and let b be equal to the standard basis of v and b star be the dual basis. Then u is equal to the span of e1 minus e2 plus e3, and u perpendicular is equal to L in the dual space, and L of e1 minus e2 plus e3 needs to be equal to 0. What is u perpendicular? So, how do we solve this problem? Well, first of all, we just formally write the definition. We have A e1 star plus B e2 star plus C e3 star multiplied by e1 minus e2 plus e3. You don't always have to write this. If you go further, you can just write the following and then work with them. It's easier, but for now we will just do a clean example, so we will just write everything. We can rewrite all of this as A minus B plus C, and this needs to be equal to 0. So we can rewrite the B as A plus C. This means every linear functional L in U perpendicular can be written as L is equal to A times E star 1 plus A plus C. Well, this was B right here, but we know that B is equal to A plus C, so we can just write A plus C E2 star plus C E3 star. If we multiply everything out, this can be written as A times E1 star plus E2 star plus C of E2 star plus E3 star. Now it's just something, how do you want to write the solution? The first way to write this is as follows, that the annihilator is the set of A E1 star plus E2 star plus C E2 star plus E3 star for AC in R. That's one way. It's probably the more formal way, but you could also write it in the form of the span, that U perpendicular, so that the annihilator space is equal to the span of the vector 1, 1, 0 and 0, 1, 1. And that's our solution. I would probably check with the professor if this is the notation he wants or this, but they're equivalent, they are literally the same. But now let's go to the second example. Now we will be going over the second example. We have the problem right here. Let V be equal to the linear span of E1 minus E2 plus E3, comma, E1 plus E2, and that the annihilator space is some function L in the dual space, where L from E1 minus E2 plus E3 is 0 and L from E1 plus E2 is equal to 0. Well, how do we solve this problem? Well, first of all, we just write that L is equal to A times E1 star plus B times E2 star plus C times E3 star. Now we can just write the matrix A minus B plus C and A plus B, and these have to be equal to 0. We got this from here. the condition right here. Condition right here is this one right here, and the condition here is the following here. So we just wrote E1 as A, E2 as B, and E3 as C. From the second equation, A plus B, we directly get that B needs to be equal to minus A. So we have, if we plug this into our first equation, we have A minus A plus C is equal to 0. We have A minus minus. This means we have 2A plus C equals 0. This implies that C is equal to minus 2A. Well, now we rewrote B with respect to A, and we rewrote C with respect to A. So we have a function which just depends on A. Now, all we have to do is just write the solution. But how do we write the solution? Well, in my personal way, I prefer the notation as V perpendicular is equal to the set of vectors which has the following structure: A times E1 star minus E2 star minus 2 E3 star for some A in R. How do we get this form? We said that E1 is A, E2 is E1 is A, E2 is B, and E3 is C. We know that C is minus 2A, so we just plug in minus 2A for this part right here. We know that B is minus A, so we just plug in something like minus B, but just with the standard vector. And that's all we have to do. So this right here would be the solution to our problem. That's it for today's video. There will be another video about the annihilator space soon, where we will just go over the formal definition and just the more theoretical stuff. But for me personally, I prefer to jump into a new subject with an example, so I just know what happens with the definition. Otherwise, the definition is just so abstract that I don't really get the essence of all the theorems and the definitions. I hope you enjoyed this video. If you liked this video, please don't forget to like and subscribe. It really helps me out. If there are any questions, let me know in the comments below. If there are any problems you want me to solve for you, please just ask me and I will look at them and try to solve them. And I hope you have a nice day, and until next time, see you.